Now let's take a look at exercise 4.4.5 in your textbook. Let event A be learning Spanish. Let event B equal learning German. Then A and B is learning Spanish and German. Suppose the probability of A is 0.4 and the probability of B is 0.2. The probability of A and B is 0.08. Are the events A and B independent? They give us a hint. You must show one of the following. And just a side note, we have a lot of given information here. Probability of A, probability of B, and the probability of A and B. So that's going to become really helpful when we try to show one of the following equations. So we only need to show one. Of the equations above. I'm going to show all three just so that you can see how they are different. And I do need to point out one more thing. There is a small typo in your book. This should read the probability of B given A is equal to the probability of B. So we'll make sure we get that corrected soon. But there is a small typo there. There should be an equation in that second bullet. So let's take the first bullet. Remember, we only need to show one. So probability of A given B, does that equal the probability of A? We have a definition for the probability of A given B, which is the probability of A given B is the probability of A and B divided by the probability of B. The last variable is always the one represented on the bottom. And since we have these values given to us up in the problem, the probability of A and B is 0.08. The probability of B is 0.2. If we divide that out on our calculators, we end up with 0.4. And a quick check up top says 0.4 is also the probability of A. So this would mean A and B are independent. Again, we only need to show one of the three equations, but I want to show you all three of them so that you know what they look like. Probability of B given A has a similar formula as above, A and B, except this time we're going to divide by A. So in this case, A and B, the probability is 0.08. Probability of A is 0.4. When we do that division, 0.08 divided by 0.4 is 0.2. And a quick check above, sure enough, 0.2 is the probability of B. And so again, we have yes, A and B are independent. And the third bullet, probability of A and B, we want to know, does that equal the probability of A times the probability of B? So we know probability of A and B is 0.08. Probability of A times the probability of B is 0.4 times 0.2. And sure enough, multiplying them in our calculators, 0.4 times 0.2 is 0.08. And again, showing independence. A good little exercise in using the definition of given probabilities with the formula in order to check if two events are considered independent.